Good afternoon, everyone. My name is Supraja, working as Assistant Professor in the Department of Civil Engineering at B.V. Raju Institute of Technology, Narsapur. Today I am going to explain friction concept in applied mechanics related to civil engineering. So first of all, we'll see what is meant by friction. So friction is nothing but it is the opposing force to the motion of any object. For example, if a vehicle is moving towards right, so this is the motion of the vehicle. So friction will be opposite to the motion of the body or motion of the vehicle. So this is the friction direction. Next one, coming to the types of friction. So there are two types of friction. One is static friction and second one is dynamic friction. We'll see what is static friction. So static friction is nothing but the friction between the two contact surfaces when the object is at a rest condition. So for example, if we see the book on the table, so this book is placed on the table. So this is not moving because the static friction is applying here. This is the self-weight of the book. It is acting always towards down. This is the applied force. Due to the applied force, this book will move like this, towards like this. So static friction will be like this. So due to the static friction, this book is stable or at rest condition on the table. This is the example. And second one, coming to here, this is the regular life example. So if you see the sofa on the floor, what happening here? So in this direction we are applying the applied force. So because of this applied force, this sofa will move towards like this. This is the motion of the sofa. But basically, because of the frictional force between the floor and the sofa, the sofa is at a rest condition. Now we have some other examples, like this is the floor, this is the ball. This ball is at static condition when there is no applied force is acting on the ball. For example, this is a block. This boy is applying some force on the block, but due to the frictional force in the opposite direction of applied force by this boy, so this block is at the static condition. Next, coming to the another example, this man is applying some force on the car, but towards like this, but due to the static friction in the opposite direction of the man force, this car will be at stable condition, that is at a rest condition. So this is called static friction. Next, coming to the dynamic friction. So dynamic friction is nothing but when an object is moving on another surface, so there will be a dynamic friction in between the contact surfaces. In dynamic friction, we have two types of frictions. One is sliding friction and second one is rolling friction. So sliding friction is nothing but an object slides over another surface, nothing but sliding friction. Rolling friction is nothing but friction between any wheels and the floor or any surface is nothing but a rolling friction. Coming to the real-time examples of sliding friction, this man is applying some external force, that is pulling force, by using this thread on this block. This block is moving towards right. So due to this frictional force will be opposite to the applied force, like this. Next, coming to the another example, this is also sliding motion. So force is applying like this. So frictional force will be like this. In this, what happened? This is the inclined surface, inclined plane. So on this is an object. This is moving towards down. So here sliding friction is resisting this object on the inclined plane. Okay. Next, coming to the another example, this is the tub activity in snow areas. So due to the inclined plane, this tub is sliding towards down. So this is the motion like this, and frictional force will be opposite to the motion here. So this is also best example for sliding friction. Coming to the another real-time example for sliding friction. So this boy slides over the sliding equipment. We can see the sliding friction in all types of paths. So next, coming to the another example. So this block is moving towards down on the inclined surface like this, and the friction will be like this, opposite to the motion of the object. So this is the skiing activity in mountain regions. So this man is sliding towards down, so there will be a sliding friction towards up, that is opposite to the motion of the man. Next one, coming to the another type of dynamic friction, that is a rolling friction. Rolling friction is nothing but wheels rolls over the another surface. So coming to the real-time examples, if we observe the wheels attached to this block, these rolls are rolling like this over the surface or over the floor. Coming here, this is a very common example, that is cycling or bicycling or car movement on the road surface. There is a rolling frictional force between the wheels of the bicycle or motorcycle or car. So this boy is moving towards like this. So there will be a rolling friction opposite to the movement of the wheels of the cycle. Next, coming to the another example of rolling friction. So there is a ball which is rolls over the horizontal surface. So this wheel is moving like this. So there will be a rolling friction between the contact surface, that is the floor, and the ball in the opposite direction of wheel direction. Next, coming to the another example, we can observe this trolley in supermarkets. So there will be a rolling friction between the wheels of the trolley and the floor. Next one, coming to the simple definition, that is limiting friction. What is meant by limiting friction? Limiting friction is nothing but it is the maximum friction between the two surfaces before an object just impends in motion. So for example, here this is the horizontal surface. There is a block on the horizontal surface. It is moving towards the right. So there will be a friction like this, that is opposite to the movement of the block. So this block will start moving towards right when an applied force is like this. So limiting friction is nothing but it is the maximum friction exists between the two contact surfaces when an object just begins moving. So here we can see the block. We can observe this block is resting on the floor. So if we apply some applied force like this, there will be a movement in the direction of the applied force. So there is an opposite force which is opposing the movement of the block. So here this block will just starts moving because of the applied force. This is nothing but limiting friction. That means where the block just starts moving is nothing but a limiting friction. Next, coming to the normal reaction. So we all know that normal reaction plays a major role. Normal reaction plays a major role in case of friction concept. So normal reaction is nothing but which the force opposes the weight of any object. So we all know that self-weight of any object acts always downwards due to the gravitational force. So the normal reaction is nothing but it is a resisting force that is opposite to the self-weight of the object. Normal reaction is indicated by capital N. Next, coming to the basic definition, that is a coefficient of friction. So coefficient of friction is nothing but it is the ratio of frictional force and normal reaction. That is, this coefficient of friction is indicated by nu. So it is the ratio of frictional force and normal reaction. So normal reaction is represented by capital R or small n. Generally, coefficient of friction is represented by nu. So it is the ratio of frictional force and the normal reaction. So normal reaction is represented by capital R or capital N. We can write this will be mu is equal to F by N, that is tan phi or tan theta, where phi represents angle of friction. That means where the limiting friction exists, in that case angle of friction also develops. This applies for inclined surfaces. So here R is nothing but normal reaction, F is nothing but this is a limiting friction where the body starts moving. Next one, coming to the laws of friction, there will be some laws of friction in case of friction concept. So coming to the first law of friction, frictional force is always acts opposite to the movement of the body. So for example, this is the surface or floor. So on this we are keeping one block. If this block is moved by the application of some external force, so there will be a frictional force, that is F, which opposes the applied force. That means this frictional force is opposing the movement of the block. Coming to the second law of friction, the magnitude of friction is exactly equal to the force which opposes the frictional force. That is, the magnitude of friction is equal to the applied force. If we consider this is the floor, so we are applying some external force like this. There will be a frictional force. This P is the applied force, F is the frictional force. So from the law of friction, this is P is equal to F. That means frictional force is always equal to the applied force. That means static friction will exist here. So when magnitude of the frictional force equal to the applied force, the object will be at a static condition, that means at equilibrium condition on the floor. Next, coming to the third law of friction. So this is similar to the coefficient of friction. That means the magnitude of limiting friction bears the constant ratio to the normal reaction between the two surfaces. So we already know that coefficient of friction nu is equal to F by N or F by capital R. So means F by R, that is the ratio of coefficient of friction, is equal to constant. Here coefficient of friction is the constant. Next, coming to the another law of friction, that is here the magnitude of friction is independent of area of contact between the two surfaces. For example, if we consider this is the floor, this is the block. So this block is occupying some area on the floor. This is the contacting area of the block and the floor. So here the meaning of law of friction, that is the frictional force is independent of area of contact between the two surfaces. Here two surfaces are this floor and the block. So this block is occupying some area on the floor. but the magnitude of friction is not dependent on the area of the contact between the floor and the block. Next, coming to the law of friction, that is the frictional force depends on the roughness of the surface. That means the nature of the surface. For example, if the surface is having more rough nature, so the friction will be more, the magnitude of friction will be more. If the surface is more smooth, in that case frictional force will be very less. For example, there will be a rain. So in that case, what happens? The frictional force between the wheels and the vehicle will be less because of wetting nature of the road surface. There will be a reduction in the frictional force. Next, coming to the applications of friction in civil engineering point of view. First one, frictional force in foundations. There will be a frictional force between the footing of the building and the soil particles during the foundations, and retaining walls. For example, there will be a retaining wall like this. So this is all consists of soil particles. There will be a friction between the retaining wall here and the soil particles. This is the contact surface between the soil particles and the retaining wall. So because of the friction here, this retaining wall is bearing the soil weight. And coming to the tire and road interaction, so this already we have seen, that is there will be a frictional force between the wheels of the vehicles and the road surface. For example, this is the road surface, this is the vehicle, these are the wheels of the vehicle. These wheels are moving like this, that is rolling friction here. There will be a rolling friction between the road surface and the tires here. So while designing the pavement of the road, we have to consider the frictional force between the road surface and the wheels of the vehicle. Next, coming to the skid resistance. This is very most important while designing the road surface. Next, we can observe the frictional force in case of bolting and rivet joints. So we are using bolting and rivet joints in case of all steel structures. So in that case, there will be a friction between the joint and the another structural element. Next, here coming to the frictional dampers. So we are using dampers in case of earthquake resistant structures. These dampers will resist the seismic waves by producing friction in between the structural elements in case of earthquake prone areas. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.